Welcome back everyone to another video in our FE Civil Preparation course. In this video, we are going to talk about soil shear strength. Shear failure is one of the most common failure mechanisms for soil and especially for slopes and embankment. If we have a slope like this one here, the most common failure mode of this slope is going to be by this portion of soil sliding in that direction. This line here is going to be called the surface of failure. So if we took a soil element here at this failure surface and started to analyze it, we will find that this element is under normal stress coming from the weight of the soil above and shear stress trying to drive the soil to slide here, and it is resisted by the soil shearing resistance developed in the same surface and in the opposite direction of the mobilized shear stress. We know that the shear stress at this surface is coming from the component of the weight of the soil in the sliding direction. So what about the shear stress resistance? The shear resistance at any surface consists of two components. The first one is the cohesion between soil particles, and the second component is the friction force between the soil particles. So the shear resistance could be calculated using the following formula: tau equals C plus sigma tan phi, where tau is the shear stress resistance, C is the cohesion force, sigma is the normal stress perpendicular to the failure surface, phi is the angle of internal friction. So let's try to graph the relation between the normal stress, and shear resistance. Let's start by drawing a relation between the normal stress on the soil in the horizontal axis and the shear stress on the soil in the vertical axis. Now let's try to plot the shear resistance. We know that tau equals to C plus sigma tan phi. So at the point where sigma equals 0, tau will equals to C. As sigma increases, the tau will also keep increasing, so it will go like this, and the slope of this line will equal to phi, which is the angle of friction. So now this is our failure surface, where tau equals to C plus sigma tan phi, and any point on this line will equal to tau, which is the shear resistance value at this specific sigma value. So now we have the resistance. We need to graph the stress at any point. So if we have this layer of soil, for any soil element here, it will be under vertical and horizontal stress of, let's assume it to be sigma C. So this point could be represented on our graph here. Now let's assume that we started adding additional surface pressure with value of delta sigma. Now the maximum stress at this point will increase to be sigma C plus delta sigma. And now the relation between the stress and the shear will be in the shape of circle, as we have earlier learned in Mohr circle. Now this element is safe under the current loading because it is still under the failure surface line. But as the delta sigma increases, the shear stress will keep increasing and the Mohr circle will start getting bigger till it finally touches with the failure surface, which means that the soil is not safe against shear failure anymore. Now that we understand the main concept of shear failure, it will be very simple to understand the Mohr circle representation and those equations as shown here in FE handbook. All those equations are available in the handbook, so you don't really have to memorize any of them. You just need to understand how to use them.